So now let's look at this particular example. I just wanted to give you a more particular concrete example to walk you through this idea of recursion with a byproduct on this particular problem. So we're back to this original tree that we started with, and I want to show you node by node, step by step, how we percolate the two numbers up. For example, okay, so first the recursion is at this node. Okay, so we're calling longest on the root node, very root node, global root node, and then it will call recursion on to this node, right? And this node says, well, I still have my children to call, so I call this node. And this node is a leaf node, so what will it return to the parent? It will return two numbers again, the longest path within me and the height, right? The height, well, what's the height of a leaf node? Well, the height of this node is 1. The height of leaf node is 0, okay? So it will definitely return to the parent two numbers. The second number is 0. The first number, what is the longest path within the leaf node by itself? Well, that is a singleton tree, a tree with only one node. Well, in that case, I would say the length of the longest tree, path is also 0. So you return 0, 0 to the parent. Okay, so I finished and I returned to my parent. Okay, return two numbers, and similarly you return 0, 0 here. Now you're back to this node, and you're given two pairs of numbers, and you try to combine using the stuff here, using an idea here, the max over 3 cases and the max over 2 cases for the height, right? The height is the max of the left and right plus 1. And the longest is the max over 3 cases. Goes through the root, only on the left, only on the right. Okay. So this number first is the longest. Let's say it is the longest. And the second number is the height. Okay. Now, what will the two numbers for this node be? Well, for the height, you just max of the 2 plus 1 is 1, because it doesn't matter. It's always it's just 1, right? The two trees, the two children are of the same height. But what number you report here? Well, it's either the first case, which is goes through the root. That is the height here, 0, plus the height here, right here, height 0, plus 2, plus this and that, 2. Okay, so it's a max of 0 plus 0 plus 2, which is 2, or only on the left, 0, or only on the right, 0. So of course, that gives you the result of 2. And it makes sense, because the longest path is indeed 2 within this tree. Okay, so then this pair of numbers, 2, 1, is reported to the root. But the root says, I have your sibling. I have something else to consider, that whole right subtree. And this guy will call the recursion here, and it will return similarly 0, 0, up, and you will call here, and this will call here, and 0, 0 is being reported up. And down here, it's also 0, 0, and goes back up. And this node, again, will be similarly 2, 1. So that means the longest path within this node, within this subtree, is 2, and height is 1. And when this pair is also reported to here, we have the first interesting case. Okay, the first interesting case is you have to merge these two pairs of numbers. So, sorry. And let's solve the height first. Height is max, height is clearly this number plus 1, because this is the higher, the deeper subtree between the left and right. So this one plus 1 is 2. And what's the maximum length of the path within this node, within this subtree? Well, there's 3 clauses, 3 cases. The first is the height of 0 plus the height of 1 n plus 2, right? So that is 0 plus 1. So let's write it. Max over the height is 0 plus the height of 1 plus 2, which is 3, or completely within left, or completely within right. That's the 2 here. So this equals 3. And this makes sense because it is indeed 3. So 1, 2, 3 is the longest path within this particular subtree, within this node. Okay, so 3. Okay. Now this pair of 3, 2 is finally reported back up to the global root node. And the global root node will again report 2 numbers to its own parent. But of course, it doesn't have a parent. It just have whoever calls it the main program. And in this case, by the way, you know that the height is no longer needed, but that's, whatever. We just still can calculate that. And the height will be max between 1 and 2 plus 1. So this would be 3. Right? And that makes sense because the height of the whole tree is 3. 1, 2, 3, 3 edges. That's the depth of the whole tree. And what's this number? This number is the number we cared about, the longest subtree within this whole tree. And again, it's the max over the height here, 1, plus the height here, 2, plus 2, which is 5. Or it's completely within left, that's 2. Completely within right, that's 3. So in this case, it's 5. And this is further returned, and only the first number is needed for the final answer, right? So that means the longest path is 5. It's indeed 5. It's either this edge 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It doesn't matter. There are 4 edges. Sorry, 4 paths. All of them have equal length of 5, right? So yeah. So every node you do 2 maxes. The second number is the max between the height plus 1. The first number is the max between 3 cases. One is the left max plus right max. So something plus 2, right? The left max, right max plus 2, right? Yeah, so and you just percolate back up. So that's the way to do recursion with a byproduct. And it's clearly all 1 time per node. After this concrete example, I think everybody should be on the same page how to implement this in Python in just 5 or 6 lines of code. Hopefully this is helpful, and I will stop here. Thank you.